Today we are going to do the experiment, operation and performance of different pumps. So we have four types of pumps. These four types of pumps are there in universal pump test rig. So we are using this test rig. So we have the four types of pumps: centrifugal pump, turbine pump, axial flow pump, and gear pump. So four pumps we have. So first we will study centrifugal pump and turbine pump today. Next week, if you have time, we can repeat another pumps. So in performance, the construction of the equipment or arrangement of the centrifugal pump is so this is a pump. This is rotated by the electric motor by using shaft and gear pulley. So we have the electric motor. This is connected by the shaft and pulley, and there is a axial flow inlet. There is axial flow inlet. So water is coming axially. So here in this case, the suction head is 0. Suction head, which is denoted by HS, is 0. And from this center line to this line, the delivery head. HT, it is denoted by HD. So it is a delivery head and suction head. Sometimes your tank is down, so we have to take from the surface of the water to the center of the pump. That is suction head. So here our water tank and center of the pump is at same level. So suction head is 0. So total head is HD plus HS. So total head is nothing but HD. So this is a total head produced. So if this pump is pumping Q flow rate, volume flow rate in meter cube per second. So our objective to find out the input power, output power, head, discharge. So how we can find? So how we can calculate this? So first step, if electric motor starts, this runs the pump at a speed of NP. NP stands for number of revolution per pump, and this motor is running at Nm, RPM for electric motor. So there is belt and gear drive. So we need to find NP. So what is the relation between, for gear drive, what is the relation? You study in 105. If this is a motor, if this is pump, or maybe vice versa, or this is motor, which is a driver, and this is a driven pump. So NP and NM. So how we can find NP? Suppose this is a gear having number of teeth TP. This is a gear having number of teeth TM. TM is number of teeth on a motor pulley, motor gear, and TP is the number of teeth on pump gear. So what is the relation for power transmission? You study in 105. Yes. NPPP is equal to NM TM. You know this relation. Or sometimes you can replace this in terms of diameter, if you know the diameter. Okay? So diameter divided by D divided by D, we can get the diameter. From that we can find out also. So here we can find out NP is equal to number of teeth on motor, number of teeth on motor, RPM of motor, and number of teeth on pump. So this we can measure the number of teeth from the gear. We can measure the number of teeth on the gear, which is on motor, and RPM we can take from the watt meter. So there is a RPM meter, we can measure the speed and we can find out NP. Now once we know the rotational power, how we can find the power? If we know the speed, how we can find power? So power, input power, right? Input power. Input power is equal to Pi. So Pi is equal to, can you tell me the power formula? A generalized formula in engineering, yes? Work done by omega or something, he is telling something. 2 pi nt divided by 60. Close your eyes and write this formula anywhere in engineering we require. Okay? 2 pi nt, this is in terms of omega also. N by 60 is omega. 2 pi omega t. Okay? So 2 pi n t over 60. N over 60 is omega. Okay? So here we have RPM, so we will use RPM, not radian per second, omega. Okay? So this is pump now, because pump is running. So here we need to find Pi, we know NP, we need to find torque. So how we can find torque? This question asked in interviews and exam. How we can measure torque? What is meant by torque? Force into distance. So if this shaft is rotating, this force into the distance is called torque. You study in 101. Torque, force into distance. So the torque is measured by using dynamometer. So there is dynamometer is fixed here. So dynamometer is fixed with this lever and weight assembly. So here we can find out this scale is calibrated in terms of torque, Newton per meter. So we can measure the torque from this scale. Okay, so this is our observation. So we have to measure torque, so we can find out power input. Now what is next? What is next objective? Power output. So how I can find power output? Output power. Power output. So PO. Now see here. This is Newton radian per second. Torque is in Newton meter. Newton meter per second is nothing but watts. This power is in watts. Okay. Now output pump power. It should be in watt. So the formula is used. This formula is very important in fluid mechanics, in engineering. Okay. So remember this formula. This is rho G. Rho G means gamma. And what is the gamma for water?
1000.
Density of water is 1000. Density into rho G is gamma. 9810. 9810 Newton per meter cube. So rho G means gamma into Q into H, head produced by motor. So this is in water because water is flowing. So I will take HW. Now check the unit. Rho G nothing but gamma.
Yes.
Rho is kg per meter cube and meter per second square. This is nothing but Newton per meter cube. So I will directly write Newton per meter cube. What is cube? Meter cube per second. And what is head? Meter. Now see this meter cube get cancelled. What we have? Newton meter per second means watt. Okay, so our unit is watt. Watt means joules per second. Newton meter is joules per second. So same watt. Now what is next objective? Next objective is we need to find input output power. Then we need to have discharge Q. How we can find Q? Yes. Measure the 10 liter volume. Measure the time for 10 liter volume and it is in meter cube per second. Then efficiency. Always we know efficiency is output by input. Output power by input. And last is efficiency of pump is equal to output by input. So it is nothing but PO over PI into 100 per percentage. 100 per percentage. Okay, so these are the formulas required. Now, observation table. How I can write observation table? So what first observations? What I need to observe? I need to observe number of teeth on motor. I need to observe number of teeth on pump. So first observation I need is number one, number of teeth on pump. Number two, number of teeth on pump, number of teeth on motor gear, and from that I will find NP. So this is a constant RPM. NM. NM also no need, I can find directly from here. NP. Okay, so this is observation table. Now table, I will write table. So first, what is my observation? Volume, serial number. First, you don't forget about serial number. Okay. Then volume and time. I need to observe. So I will write volume. V liter. Volume V liter. Then I will measure the time for that. Time in second. This is observation. Next.
Then NP.
Class, I calculated. This is the first time on constant speed. So constant speed I found now. Okay. Now input power, output power. For that input power, what I need? Torque. This is not number of teeth. This is torque. Okay. So I need to measure torque. T in Newton meter. Okay. Then power output. I need Q, H. Okay, I need H. So head. So head I will write here suction head. Suction head. HS. It is always 0. Okay, it is always 0 for 4 rings. Then delivery head. Delivery head. It is HD. So it is in meter. It is in meter. It is in meter already given. And total head.
Teacher, HG?
1 minute. Total head H is equal to HW is equal to HS plus HD. HS plus HD. Okay. So this we need to measure. There is a pressure meter here. It is showing in meters of water. So this is a pressure head, pressure gauge. The reading, the unit is in meters of water directly. So it is called head. So we can measure head for centrifugal pump, for axial pump, for gear pump and turbine pump. The suction head is kept at 0 because of water level. Okay. So these readings we have to take from there and we can do it. Now how to write the calculation table? Calculation table. Calculation table. So first is
Unit Q.
yes, serial number. Already we have serial number. Now what we can calculate easily? Q.
Yes, Q.
Discharge. Discharge Q. Meter cube per second. Formula we have already. Then what we find?
Power input.
Yes, next is power input. Power input.
Power output.
PI in watt. Watts. Power output.
Efficiency.
Output. PO in watt. Watts. And efficiency. Last is
Efficiency.
efficiency. In percentage. Is it easy? No need to memorize table. We can write on your side. Okay? So this is the table. Now we'll take the readings. Now how to take the readings? Here we can. Okay? So first we need to calibrate this dynamometer torque measurement scale. Okay? So here see, this is not resting. This is not resting on the notch. Now it is resting, so you can see. Sometimes it will be like this. Sometimes it will be like this. So keep it on the notch. Keep it on the pivot, okay? Now, keep this on 0. Keep this on 0, okay? Open the door. So this is a safety knob. So if you open the door, the machine will be off. The machine will be isolated, okay? If you open the door. Now, see here, this screw. We need to lose it. Okay, so by these two hands, keep the two hands on the gear, and we can move this like this. Okay, so keep this at the center and tight it. Okay, so tight it. Now next, you want to select centrifugal pump or axial or gear or turbine. So this belt we need to connect. Connect to this pulley, this is turbine pump. Centrifugal pump here, gear pump there, and axial pump here. We need to connect by this belt. Okay. Now first don't collect the belt. Tight this screw and run the motor with a no load. Means electric motor is under no load because we remove the belt. Okay, so connect this cable. Make sure the speed is at 0. Okay, connect this to 110 volt. Okay, then switch on this. What happened? It is not on. Yes, sure. So door is open. Okay, then now on. So this is not working. Maybe this week I will replace it. This regulator we can replace by time, so it will be increase the speed. Okay, so this is the motor is running under no load condition. There is 0 load. Now keep this on 0 and adjust this weight to this notch, and this line should be lined. See now, if it is like this, so make it little back. It is down, so I will take it little back, and now you can see.
Direct.
So, is it done? Yes. Yes. Is it in line? A little. I will take it little back. Yes. This is in line. This line and this line is in same level. Okay. Now means we can say the dynamometer or torque measuring scale is calibrated. Okay. So we are going to use these readings down. Okay. So here now I will switch off the pump. Motor. I will switch off the motor. Oh, sorry. So reduce the speed. Make it 0. Okay. Remove the cable for safety. Open the door, and now first my target is centrifugal pump. So this belt I need to connect. Before that, what I need? Before connecting belt, what I need?
Measure the
Alignment already, not necessarily
Number of
alignment
teeth.
here. Number of teeth. So there is a chalk piece. This why we need, because chalk piece we will repeat again and again. Okay. So here, see this is a pump, centrifugal pump. So I will mark somewhere here. Okay. And now this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
7.
So right there, 17. Yes, take this. Number of teeth on TP. Right, TP 17. So here I will mark now. For motor. So this is a motor. Here is motor. So I will mark this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23. Okay, so we know number of teeth. Now we'll connect this belt to this. So to connect the belt, remember, Shabab, see here. So to connect the belt, we need to release this knob. Release this knob. Put your two hands to on gears and little swing. Okay, little swing. Keep this here and keep this here. So this is loose. Now make it tight.
Bring it back.
Yes, bring to the horizontal position. Now this is a horizontal position. By hand I can see it is rotating. Okay, so this is alignment. Khalas. Now tight it. So don't touch this. Only this for swing. Okay, to release the belt and to take the belt out or fix the belt. Okay, and fix it. Now close this door. Okay, connect the cable. Connect the cable 110, not 220. Then make the speed 0. So this is a full speed. Make the speed 0. Okay, and then switch on. So it should be 0 speed, but this is not working. I will replace this. Okay, so it is full now. So the motor is running at constant speed. How much speed? 0. So this is 500, 600, 700, 750. So each reading 50. The distance between two consecutive lines is 50 RPM. Okay, into 100 is there. So 500, 550, 600, 700, 750. So speed is 750. No. Which speed? This speed is motor speed. NM. Right back that there. Yes, 1 minute. Give me here. So I will write here. NM is equal to 750 RPM. RPM. So I will put this value and I calculate pump. Okay? And then we will write. Or you can write here NM and NP is equal to RPM. So this is 750 measured and this is calculated. Okay? So we calculate this. After that, now water is flowing. So see here, this wall should be completed before starting the pump. Before starting the pump, this wall should be completely open. And which pump we selected? Centrifugal pump. This should be open. It was closed and the torque was maximum. Okay, so this wall should be open. So this is open. Yes. Clockwise direction. This is anti-clockwise direction open. Anti-clockwise direction open. Okay, so this is completely open now. Now water is coming. Okay, so here remember, I started immediately. No, first open this fully open, start pump at 0 speed, then increase the speed. Okay, now this is fully open, and we will adjust the torque. So how to adjust the torque? So move this lever, so take this, it is on the knob, and now move this and adjust this line. Is it correct? Is it in line? Now measure the torque. Measure Q. 14 meter. Okay. 14 liter. We can measure the time. Okay. Now what is the value? See here 0.5, 0.6, 0.7, 0.8, and I will see it is near 0.9. See 0.5, 6, 7, 8, 9, and this is 1. So I will move it. Yes, 0.5, 6, 7, 8, little 9, less 9. So 0.89 or 88, 89, so it doesn't matter, okay? So we'll write 0.89. What is this torque? Torque 0.89, 5, 6, 7, 8, little less to 9, okay? 0.89. Let's measure the Q. Close this. And measure the time from sit down here. Yes, from 0 to 10 we can write 10 liter. Okay, so tell him the time. Okay, next reading. Okay. Okay, now next reading. It is important how to do this. Now our speed is constant. We are not going to change the speed. We are going to change the Q, volume flow rate. So this is, I will operate for centrifugal, I will operate this. Actually we can operate this, but we can operate this also, no problem. So we'll operate this, reduce the discharge. Now it is full discharge. So reduce the discharge clockwise. Reduce the discharge, so how much? Oh sorry, we took the readings HD? No. So this is HD, centrifugal pump. What is HD? This is 2, 3, 3.5, 4, 4.5. So you can write 4.5. HD, delivery head,
4.5.
4.5. Okay, now first reading done. First reading done. Now second reading, I will decrease the flow rate from here. See, the head will increase. Is it 5? No. Yes, 5. So you can write head 5. Okay, close this and measure the time. Yes, measure? Yes. I will tell you. Yes, you are measuring now. Now measure the head. You want to measure the head from, sorry, torque. Yes. So torque, how to measure torque now? Move this, make this line. So this is, yes, little. Leave now. Leave your hand. Take again. No, it is down, means we have to move there. Just let it. Leave your hand. Yes. This is carbon. Again. The pump was off. Close. Now head is correct 5?
Yes, fine.
Yes. Now you check this. Yes. Now measure the torque. Yeah, start this. Measure the torque. 0.5, 6, 7, 8. 8.5. 0.855 or 84. 0.84 you can write. 0.84. Okay, you understand now? So now if you decrease it, you have to move that side. Okay, now next reading you can perform. Okay, yes, right. Make the speed 0. Make the speed 0. Okay, and switch off this. Okay, so keep it open fully for next maybe. So this is closed now because I get it closed. I close it, it is open. Now for next pump, remove the belt, select the gear pump, measure the number of teeth on the gear pump and motor pump, electric motor and gear on electric motor and gear on pump. Measure the number of teeth. Then change the belt. So before changing belt, remove the belt, start motor, adjust this to 0, adjust the weight for straight line, okay, and run the motor for few minutes, adjust this 0 and make this straight by this weight, by moving this weight. Okay, so once done, switch off the motor, open this and fix the belt on gear pump or turbine pump. We are using turbine pump. So we'll take a break. After the break, we'll start the turbine pump. Okay, so you have to do the turbine pump. I will not do.